Hey guys, how you all doing? It's Jalajora here again, back with another video from Biogem at GCSE Chem, and today we're going to be doing section C4.8, which is called Titration Calculations, and this is also for triple science students only, so not for people studying or students studying combined science. And in fact, the next section is also for triple science students only, which is C4.9 volume of gases. So volumes of gases. So basically, what that means is that if you're doing double science, which is also known as combined science, you can actually start on these questions. Actually, over here, here are the questions that you can do if you have this book. They're on page 36. There, here you have the summary questions. And make sure you're only doing the ones that are not triple science students only, because you're not going to be testing on them if you're doing combined science. Obviously, you're not going to be testing on triple science topics if you're doing combined science, obviously. And also on page 37 and 38, you have questions as well here. These are summary questions for the first 4 chapters, so you can really test your understanding. How well you've understood the first 4 chapters. It will really help for the exam. So you can do that. But if you're studying triple science, first, finish these, finish today and tomorrow, then you can have a go at these questions. Once you've done the whole one, once I've done the whole kind of chapter, with just 2 more sections left today and tomorrow. So today is all about titration calculations, and it's C4.8, so that's called Titration Calculations. And here's the book I'm using. So here's the GCSE Chemistry, AQA GCSE Chemistry Revision Guide from Caboodle. That's the book I'm using there. And I haven't been able to put the links up to the videos from C3.2 to C4.7. I'll try and do them up by today. If not, I'll actually try and do them by tomorrow once we've done the whole chapter. Once we've done the whole chapter 4, so I'll put all the chapter 3 ones that I haven't put yet, and the chapter 4 ones. So I'll update all the I'll update my website and put the links to all the videos I haven't done already. Basically, I haven't put on my website already, if that makes sense. And where am I going with this? I'm on the wrong page. There we go. And if you're following the student book, it's pages 76 to 77. And also, what else do I need to say? I got my fan here because it's really hot. Well, I'm feeling really hot. It might not be hot, actually. I don't think it's very hot today. I just feel hot, so I've got the fan on. And let's begin. So I've got some pen and paper and also, I'm taking the paper away. My calculator as well, because I'm going to need it for the titration calculations. So if we're following the student book, it's pages 76 to 77 that you're looking at. And this is for triple science students only, and this is for specifically for students studying triple science higher, not for students studying triple science foundation, I'm pretty sure, because it says higher, because here it says obviously higher. It says higher, and it's a GCSE combined GCSE triple science topic, so GCSE chemistry topic basically for triple science students. That's why I don't think it's for triple science foundation students. But let's begin. So it's pages 76 to 77 of the student book that you want to be looking at for this lesson. And let's begin now. So titrations are used to find the volumes of solutions that react exactly. We've been through that yesterday. So I'm not going to go through that really. You just need to know that. Find the volumes of solutions that react exactly. So this could be acid and alkali. And if you have a known volume of alkali, you want to work out how much, what volume of acid is required to neutralize that volume of alkali. So obviously that is that known volume of alkali. So that's basically why we use titration. So it could be the other way around as well. If you're given the known volume of acid, you want to see how much alkali is required to kind of neutralize that acid. So then you can carry out a titration basically. If the concentration of one of the solutions is known, so that could be the acid or the alkali, and the volumes. Oh wait. 1 minute. And the volumes that react together are known, you can calculate the concentration of the other solution. You can use this information to find the amount of substance in the sample. So I'm pretty sure that wouldn't have made sense what I said, but we're going to go through an example, so don't worry about it. go through 2 examples actually, or maybe 3. I don't know. We'll see how many are there. I think there's 3. But yeah, so you can calculate the concentrations using balance symbol equations and moles. So so now we're going to go through a worked example, which is titration calculations. As you can see here, there's a worked example which I'll go through. And I'll go through the method that I find very helpful. So a student found that 25 centimeters cubed of sodium hydroxide with an unknown concentration reacted with exactly 20 cm cubed of 0.5 mole per decimeters cubed hydrochloric acid. What was the concentration of the sodium hydroxide solution? Now what I'm going to do is I'm going to actually show you what I do in each step. So first thing, when I've been told, when I've read the question, I'm going to write down what I know. So I'm going to write down the balance symbol equation first. So I have sodium hydroxide reacting with an unknown concentration reacted this of hydrochloric acid. So sodium hydroxide is NaOH, and you're expected as triple science students, and especially triple science higher students, and even triple science foundation, I'm pretty sure you're expected, and even in combined science, whatever, you're expected to basically know how to write down these formulae. So sodium hydroxide, you need to know Na1 plus, Na has a charge of +1, and then and then the hydroxide O minus, so 1 minus, so that's why it's NaOH, and I'm reacting that with hydrochloric acid. I don't think we've been through this specifically, but acid and alkali react to form salt and water. So sodium hydroxide plus hydrochloric acid would give me NaCl, which is my salt, plus H2O. I think we're going to go through that later, but you would have probably done this in school anyway, in class. So it's pretty basic. And then I can basically see this. So this is my equation. But I'm trying to see if it balances. I'm going to first see if it balances already, or I need to do something. So 1 sodium on the left, 1 on the right, 2 hydrogens on the left, 2 on the right, 1 oxygen on the left, 1 on the right, 1 chlorine on the left, 1 chlorine on the right. So it all balances, which is good. Now, with the elements, the species in the equation, I'm gonna basically write down what I know for them. So I'm gonna basically, I've been told what the numbers for. I've been told quantities for sodium hydroxide and hydrochloric acid. So that's why, because I said, I've read the question before. So what I'm gonna write is I'm gonna write NCV. That's the method. Remember the NCV method for titration calculations. That's why I call it the NCV method. So this is what I have right now. The reason why I put it on sodium hydroxide and hydrogen chloride is because I've been told numbers for those specific compounds. So I've been told 25 centimeters cubed of sodium hydroxide, and I've been told 20 cm cubed of 0.5 mole per dm cube hydrochloric acid. So these are basically numbers, and I've been given them for these specific species, these specific compounds. So in the balanced equation. So now I'm going to write down what I have. So remember, always work in decimeters cubed. So if you have something in centimeters cubed, unless obviously told in the exam, unless told otherwise, you always convert from centimeters cubed to decimeters cubed. So here we have 25 centimeters cubed sodium hydroxide. Now 25 centimeters cubed, you need to divide that by 1,000 so that you can get it into decimeters cubed. We've been through this before. If you're going from centimeters cubed to decimeters cubed, you're dividing by 1,000. So 25 divided by 1,000 is what? 0.025, I believe. Let me just make sure. It's quite easy, but just want to make sure that I'm not going wrong here. Yep, 0.025. Now that's how many decimeters cubed you have, and that's your volume. And what else have we been told? We haven't been told the concentration. We want to work out the concentration of the sodium hydroxide. Alright, cool. So that's what I've basically done. We've been told this, so I put a question mark on the concentration for sodium hydroxide, because that's what we need to work out. Hopefully you can see that question mark there and everything. So now what else have we been told? We've been told that it reacts with exactly 20 cm cubed or 20 centimeters cubed of 0.5 mole per dm cubed of hydrochloric acid. Now first we have 20 cm cubed of hydrochloric acid. Well, that's obviously in decimeters cubed, that is 0.0020 decimeters cubed. Again, dividing by 1,000 to go from centimeters cubed to decimeters cubed. Is that... Wait. Oh no, sorry. 20 divided by 1,000, I got it wrong, wait 1 minute, 20 divided by 1,000, I should do this right. It's 0.020. Ignore that scribble there. 20 divided by 1,000 is 0.020 decimeters cubed. So 20 centimeters cubed is 0.020 decimeters cubed and not 0.0020 decimeters cubed. So it's 0.020 decimeters cubed. That is 20 cm cubed in decimeters cubed. Now we've also been told the moles per dm cubed. So that's the 0.5 moles per dm cubed. So that's the concentration. So that's the concentration that we've been told of hydrochloric acid. So far I've just been putting the information and converting it. Now we need to know the formula. I don't know if I've been through this before. I haven't been through this equation before. You need to know that the number of moles, N equals CV. That's the equation. That's another equation that you need to know. N equals CV, or N equals C times V. So number of moles equals concentration times volume. So basically we're going to work out the number of moles of hydrochloric acid because we know its concentration. So we're going to do 0.5 times 0.020. That's going to give us 0.01 mole of hydrochloric acid. And I'll just write here what I did was I did the concentration times the volume. So here you can see I've worked out the number of moles now of the hydrochloric acid. I did that by multiplying the concentration that was given and the volume that was given, but I had to convert the volume to decimeters cubed before I could use that number of moles equals concentration times volume equation. So I've worked out the number of moles of hydrochloric acid now. Now I need to work out the number of moles of sodium hydroxide. Now in the balanced equation there's a 1-to-1 ratio between hydrochloric acid and sodium hydroxide. So the number of moles of sodium hydroxide is then therefore also 0.01 mole. So that's how many moles we have of that. Now we just need to rearrange the equation to work out concentration of sodium hydroxide. And if number of moles equals concentration times volume, then if we divide by volume on both sides, we're basically going to get that concentration equals number of moles divided by volume. You need to be very, very confident with actually doing this. So concentration C equals N over V. So this is for this is for NaOH. So C equals N over V, which I'd basically work out as well. So it'd be 0.01 mole over 0.025 dm cubed. And basically what I have is I'm going to divide this by 0.025 dm cubed. I'm basically going to get 0.40 mole dm cubed. So that's the concentration of sodium hydroxide. You can see I've written sodium hydroxide NaOH here. Concentration equals moles over volume. I've done that calculation. 0.01 divided by 0.025, and I get 0.4 mole per decimeters cubed. And that's exactly what the answer is here. So if you want to see the working out, they've done pretty much precisely the same thing as what I've done basically. And here is that working out. I hope you can see it. Trying to be very clear when I'm showing it. Oh, already 13 minutes gone. Alright, cool. In the video. So notice that so now we're going to the question. Now we're doing this. So notice that in the answer to the question above, the concentration 0.4 mole per decimeters cubed is given to two significant figures. This is to be consistent with the data given to the least number of significant figures in the question. That is two significant figures and 0.5 moles per decimeters cubed. Now that's actually a very, very important point. In the question, the maximum number of significant figures we're given is 3 in the question. So that's 20.0 centimeters cubed and 25.0 centimeters cubed. They're 3 significant figures. But the lowest number of significant figures here is 0.50, so that's 2 significant figures basically. That's the concentration of hydrochloric acid is 0.50. That's given to 2 significant figures. So we have to give our answer also consistent to 2 significant figures. It's very important that you write 0.40 and not just 0.4. So that's very important actually. You could lose marks for that, I'm pretty sure. So, and then here we have a question. It's actually the first question of the section. I was just going through the worked example there, but there is the actual question. 15 centimeters cubed of 15.0 centimeters cubed of hydrochloric acid reacts with exactly 25.0 centimeters cubed of sodium hydroxide that has a concentration of 0.1 moles per decimeters cubed. Calculate the concentration of hydrochloric acid in moles per decimeters cubed. So this is exactly the very similar question to the one before, in the worked example, just different numbers used. Again, I'm going to write down the equation. So again, it's sodium hydroxide with hydrochloric acid. Remember, it might not always be sodium hydroxide and hydrochloric acid. It is in this case, but it's not always going to be. So NaOH plus HCl gives you NaCl. So obviously first I'm going to write down the equation plus H2O. I'm pretty sure that is all balanced. Just to make sure again, yeah, that is all balanced already. Now again, remember my NCV method. So I'm going to see what quantities have I been given, and for what species of the equation, for which species of the equation do those quantities correspond to. So 15.0 centimeters cubed of hydrochloric acid. So I know there's something to do with hydrochloric acid. So I'm going to write NCV. So I'm going to write NCV there, and I just write colons next to the N and the C and the V. And then I have with sodium hydroxide, I've been given information, so 25 cm cubed, 25.0 centimeters cubed of sodium hydroxide concentration, that has a concentration of 0.10 mole per decimeters cubed. So then I know that also there's some calculation that we have to do with there's some values given for the sodium hydroxide as well. So now I'm going to basically put them in. So we've been told 15 centimeters cubed, 15.0 centimeters cubed of hydrochloric acid. So that means, remember, 15.0 centimeters cubed, you have to convert that to decimeters cubed, so you have to divide by 1,000. And I'll just make sure I'm doing this right. I don't want to make another mistake like last time. I made a slight mistake, and I corrected it, but it is 0.015, and that's the number of that's the volume of the hydrochloric acid. So that's 0.015 dm cubed. Cool. Then what I have is it says it reacted exactly with 25.0 centimeters cubed of sodium hydroxide. So now I have the volume of sodium hydroxide as well, which I need to convert to decimeters cubed. So 25 centimeters cubed equals 0.025 decimeters cubed. So that's the volume again, 0.025 decimeters cubed, remembering to divide by 1,000 to go from centimeters cubed to decimeters cubed. And then I've been told the concentration as well for sodium hydroxide, and that is 0.10 moles per decimeters cubed. I don't need to do anything to that because that is just concentration is always in moles per decimeters cubed. So by the way, that's it. Okay, By the way, you could write moles slash dm cubed, or I write mole dm to the minus 3, because in A level you normally write mole dm to the minus 3, but in GCSE it's most common to write moles slash dm cubed. But actually in the last video I actually showed you how both of these things are the same. So don't worry if I wrote mole dm to the minus 3, or if you write mole slash dm cubed, it's just the same thing. And I've shown that in the last video how that is the same, but I'm not going to show that again. But basically this is all the information that I wrote. I just took that from the question and then converted the volumes to decimeters cubed. That they were originally in centimeters cubed, I just divided by 1,000 and I converted them to centimeters cubed. So this is the second example here. In fact, what I'd do is I'd probably write, this is the 1, this is 2. So now we're looking at 2. So now we're looking at 2 here. Now we're looking at 2. So we're looking at this one, just to make it clear. And so now I can work out the number of moles of sodium hydroxide I have, because remember N equals C times V. So the number of moles equals 0.10 times 0.025. And that's 2.5 times 10 to the minus 3. Which, if I'm going to do my work, if I do this properly, 2.5 is going to be 0. Wait, if I do 2.5, 0.005, 0.0025 mole. If I do 1, 2, 3, yeah. So that's basically, you could write 2.5 times 10 to the minus 3. I just wrote it. That's in standard form. I got it on my calculator. But you could also convert it in normal form, which you just divide by 1,000. 2.5 times 10 to the minus 3 is basically 2.5 divided by 1,000, which is just 0.0025. So that's the number of moles of sodium hydroxide. Now again, in the balanced equation we can see, because this is basically the same balanced equation as the worked example, it might not always be the same, but the ratios are obviously For sodium hydroxide to hydrochloric acid, it's 1 to 1. So therefore, the number of moles of hydrochloric acid is actually 0.0025 mole as well, because it's 1 to 1. If it was 1 to 2, if the sodium hydroxide had a sodium hydroxide to hydrochloric acid was 1 to 2, then you'd obviously double the number of moles of sodium hydroxide to get the number of moles of hydrochloric acid, but because it's 1 to 1, it's all the same. Then we know that number of moles equals concentration times volume, so rearranging that to work out the concentration of hydrochloric acid in moles per dm cubed would be the number of moles divided by the volume, because remember N equals C times V. So therefore I'm just going to write that C equals N, so this is for HCl, by the way, if I just do it, HCl, C equals N divided by V, which is the number of moles, which is 0.02, sorry if I write 0.025 0.0025 mole over the 0.015 dm cubed. If I basically do that on my calculator, divide that answer by this, because it's obviously 15 centimeters cubed, isn't it? It's 15 centimeters. Yeah, okay, cool. It's 0.015. Yep. So I should get 1 over 6, so that's obviously 0.2. So I get about 0. I need to give my answer to two significant figures here because it's consistent with the least number of significant figures, which was 0.10 moles per decimeters cubed, which was the concentration of hydrochloric acid. Sodium hydroxide. That was to two significant figures, so that's the smallest significant figures in the question. So that's why my answer should be 0.17 moles per decimeters cubed as my final answer there. I'll check that, and then we're nearly done with this section today, guys. 0.17 moles per decimeters cubed. So hopefully that makes sense. You could either write moles / decimeters cubed or moles dm to the -3. That's fine either way. Now on the up, it says if you're aiming for the highest grades, you should be able to use given data to do multi-step calculations, giving your answer to appropriate number of significant figures. So this is an example of multi-step calculation which you could be asked to carry out in the exam. And this is basically the question that we were doing. I don't know if you can see it properly, but there we go. Or you can just hear it from me in the video if you couldn't see it. But basically there it is. And then there's also another question here, which I'm not actually going to go through. This is for you to do now. We've gone through two examples, so they're pretty much similar. It's just now that they're using sulfuric acid here instead of hydrochloric acid. So you're going to have to make the equation and balance it up yourselves. I'm not really going to go through this one. Or what I'll do is actually I'll go through it maybe in the next lesson. I'll give you a chance to do it, and then in the next lesson I might I'll maybe give the answer out, basically by working out. I'll give the answer of what it should have been, so you have a chance to work it out. Or I'll give the answer to this one. But basically the question is 25 centimeters cubed of sodium hydroxide solution, volume of 0.5 moles per decimeters cubed sulfuric acid needed to neutralize it, and you're given 3 experiments: experiment 1, experiment 2, experiment 3. Experiment 1 is 21.2 centimeters cubed, experiment 2 is 20.0 centimeters cubed, and experiment 3 is 20.0 centimeters cubed as well. So experiment 2 and experiment 3 are both 20.0 centimeters cubed, and experiment 1 is obviously 21.2 centimeters cubed. I'll give you a hint here: it's always 0.1. You always use the results which are within 0.1 centimeters cubed of each other. So that's, you take an average of those, and then basically you use that for your mean titra. And in the question it says, from results like these you can calculate the unknown concentration of a solution, in this case sodium hydroxide solution. In this case sodium hydroxide solution. In titrations you usually put the alkaline solution in the conical flask and the dilute acid in the burette. Normally you put the dilute acid in the burette. It could be the other way around, and obviously the alkaline solution, which is sodium hydroxide, in the conical flask. So so basically what you're given is, you're given the volume of sodium hydroxide, you're given the volume of hydrochloric acid, but you have to work out the mean volume obviously by making sure you take results that are within 0.1 centimeters cubed of each other. I've already told you what the experiment volumes are. Experiment 1 was 21.2 centimeters cubed. Experiment 2 was 20.0 centimeters cubed, and experiment 3 was also 20.0 centimeters cubed. And remember, that was the volume of the sulfuric acid, because normally here they're saying the acids in the burette. So you obviously have to take results which are the two of the results here to experiment 2 and experiment 3. You have to take an average of those results to give you the mean volume, because they are the only two within 0.1 centimeters cubed of each other. 21.2 is not within that range. So I'm going to give you this question to try out yourself, and I'm then going to go through the answer in tomorrow's lesson by working it out myself. But now I'm just going to go through the key points. So you can use titrations to find unknown concentration of a solution. You need to know the accurate concentration of one solution. Then once the endpoint is established, the balance equation gives you the number of moles in a certain volume of solution. And then finally, the value is multiplied to give the concentration in moles per decimeters cubed, which we can convert in grams per decimeters cubed if necessary. We've been through that before as well. So basically, you should know how to do these titration calculations. This is a question that there's a question here. I'll show you it again. I'll show you. Here's the question basically, if you can read it. But I've given you the sulfuric acid and the sodium hydroxide question. That's one for you to try out. I'll be going through the answer. I'll just give the answer in the next section. I won't be going through the working out as such, but there you go. Hopefully you can see it there. But try that one out and see if you get the right answer, and tomorrow you shall know the right answer, basically, if you were right or wrong. But yeah, that's the end of the section, guys. I really hope this video was helpful. Make sure to share, like and subscribe, turn the notification bell on if you haven't already, and so they are updated and notified basically when I upload new videos that you can watch. And I'll try and put the links up to all the videos from C3.2 to now C4.8 on my website, including the Why Should You Pick A-Level Chemistry video. Obviously, I'll put that one up as well by today, if not by tomorrow, because tomorrow is going to be the last section of the chapter C4.9, which is all about volumes of gases. I believe that's what it's called, isn't it? Yeah. So that's what I'll be going through tomorrow. But yeah, until then, have a nice evening, and have a nice, well, it's not really evening now, but basically whatever. See you tomorrow, guys, and thank you very much.